Hello everyone, I am Nandan and let me introduce myself. I am Nandan and I am going to be your tutor, a lecturer throughout this entire lecture package on aerospace engineering. This is a zeroth introductory lecture without any technical nitty-gritty or content to quickly explain you what this entire aerospace package is about, and specifically 3 questions: what it is, what is it not, how to use it. Extremely important questions, because these questions need to be addressed upfront before you understand and go into the technical details of this course and start getting familiarized with all the content. Aerospace is a complicated, vast and extremely interesting subject. It is actually a pinnacle of multiple fundamental science and engineering disciplines which integrate from disciplines such as mechanical, chemical, metallurgy, electrical, electronics, computer science, and even some of the other branches such as nanotechnology or basic sciences and so on. Right? Why? Because just flying as an art evolved only in the last 100 years, and so it requires a substantial understanding of these basic sciences fundamentally to tell you what it is and what it is not. Now, this particular course is not particularly linked to any one particular entrance examination or any one particular undergraduate or graduate syllabus. It takes into account multiple basic disciplines of aerospace, gives you a package around those topics and helps you learn. Right? So what is it? It is one technical series of lectures which are very coherently and in a very logically structured fashion are arranged as a complete lecture series tree, and it has typically 5 parts: aerodynamics, propulsion, space flight, flight mechanics, and structures. These 5 interdisciplinary points of aerospace undergraduate syllabus are covered in a set of logically concrete lecture steps. We will keep calling them as chapters. So in aerodynamics, for example, you would see chapter 1, chapter 2, chapter 3, and then sub-chapters and so on. The lectures are also named in a systematic logical fashion to reflect their subject, followed by the chapter, followed by the sub-chapter, and further followed by the lecture chunk, either A or B, depending on how is it. So that's a very beautiful issue tree as it expands, a series lecture tree. Right? Second, know one source of reference. For each of this topic, the best of the basic gold standards, as we call, are utilized, concised and synthesized, and then put into a concrete set of logical steps. Aerodynamics, for example, Anderson is one of the Bibles which has been used as a base reference. Some of the coaching materials which are supported by this coaching classrooms are also used. In basically the flight mechanics, we have used again the Andersons and some other points. In structure, Megson and Timoshenko are used. So no one point book or one particular coaching material or note is referred. It is a set of best which is possible along with my individual expertise and experience in aerospace. So that's the set you will see. So if you see any specific reference to a particular question from a reference source, you can expect that, but it is not the only source that you will see. So always carefully listen to the points which I will be making and then try to correlate them whatever reference you are using it so that it is further reinforced. See, this lecture series is a package of technical teaching plus mathematical abstract equation teaching plus practical practice problem tutorial. These disciplines are such complex, vast and important that we have to segregate every subtopic into 3 logical points. A theory, a basic technical teaching. For example, if I am looking at aerodynamics and one particular topic about a fluid flow over a cylinder, first we have to have a very qualitative physics understanding of that particular topic which is covered. Then you need a set of mathematical abstraction, mathematical equations, a set of mathematical derivations, empirical formulas, and then correlating these qualitative aspects to these mathematical properties. In this, the most important emphasis has been given to logically derive this series here, so that all these equations which have been derived or the empirical relations, formulas which have been found are not written simply as a piece of formula, but are explained term by term how they have come, what is the significance, and what role it plays in your technical understanding. This both is followed by reinforcement practice problem tutorials, which you will see for almost every chapter in this series, which takes a set of GATE plus other problems. So this material is not intended just for GATE passing, but other questions and problems are also integrated so that this reinforcement happens more concretely. So these practical problems are taken, solved step by step so that you are very clear for all of the concepts covered in these subtopics. Then you can go back and practice further problems from any source of reference that you may want. So this is about what it is. Now, what is it not? And this is extremely important as well to understand when you use this material. 1. Not a only study material. To teach you only through this video coaching mode, it would take at least 600 hours of coaching, which is not efficient, which is not right from student psychology point of view, and which is not a great way of learning. Learning as a pillar always have audio-visual interaction, book reading, practice problems, study circles, and so on. I don't have to explain you more. You have already been undergraduate students and you have been in a mature stage of life where you have already understood that just relying on one medium is not always great. This is to give you the best flavor in most concise manner, as we said, about all the disciplines, but not to make you master of any of the topic. So it is not the only study material. It is not a master's course. So if you go into an academy, university, or any postgraduate university course, for aerodynamics you would have a 6, 8, 12 credit courses sprinkled over semesters, where you will go much deep, much in very, very rigorous mathematical basis and formulations, and then some simulations and so on. That's master's course. This lecture series is not a master's course. It is a summary, a nutshell, the basic concept, feasibility understanding, like a crash course to explain all of these chapters, sub-chapters and topic. Don't expect to be ME or MTech out of this course. You are expected to summarize, revise, understand and be thorough with all undergraduate concepts. Third, this course is not only for GATE. It is designed primarily by keeping GATE examination in mind, but for any competitive examination, entrance examination, or even interviews as you face in your industrial orientation trainings, this is about aerospace engineering as undergraduate topics more. It will help you surely for GATE, for other exams, maybe for your postgraduate other entrances, maybe for your interviews, or just refreshing and revising your knowledge as you progress in your undergraduate syllabus itself. Because I have seen by the time you are in the 4th year, the fundamental concepts start shaking. You are going into advanced courses, people assume that you already know some things, right? Your professor would be assuming, no, you have already done basic aerodynamics, why would I have to explain you that again? And that time you may feel shaky, that oh, I really have not understood that well in my first year. This course will help you to brush that up. So it is designed primarily by GATE objective, but not only for GATE. Right? So the second question is also answered. How to use it? The best way I would recommend to use it is take a piece of paper or a notebook in your hand, go start with your lectures. When I'm speaking in these lectures, we have a liberty to pause and play. So as I keep speaking, one concept I've always put already in all these verbatims that I will be looking at, verbal clues that one particular concept is ending, one particular concept is starting. Pause there, write down your set of questions on that piece of paper, and always remind yourself to revisit them at the end of the lecture. My lecture flow will always be, I start and open up with what this topic is about, link it to the previous topic if any from which we have started to reinforce that linkage and basic concept, flow through it, at the end of that concept to again re-emphasize what we learned and summarize, and then go to the next part. So use this flow in your mind also to train your mind to absorb my lecture in that fashion. In my lecture, when I am actually explaining you qualitative part, please look carefully more towards my lecture words rather than this board, because I would be explaining with the help of qualitative hand images, or I would be bringing actually a small aircraft model, for example, in flight mechanics to explain you. I would be using even simple object like duster to explain you. So look at that analysis understanding by looking at my words and understanding more rather than looking at mathematics. When I'm explaining you the mathematics, please focus on every step, how it is done, why is it done, and understand my explanation as I'm writing. That derivation is not most important, understanding the steps and my logical reasoning of physics is most important. When I'm solving the problem, please refer to the steps and my explanations of what I did something, what I didn't do. I will always try to trick you intentionally in few times by writing something wrong. Then going back, rubbing it and explaining you why did I write. This is to go in the foot of actually to imagine myself as a student and logically question what errors or troubles or problems the students will face, what errors they will make, and intentionally repeating them here. If you are lucky, if you are smart, and if you are paying correct attention, you would be able to capture them. Please note that on your piece of paper. And see then how did I correct. If you have not been able to capture it, then see how I am explaining and keep a note of those errors. Those are the pitfalls to avoid, not to make. So that's another way of looking at it. Another thing is, don't jump in the lecture tree, otherwise you will feel confused. Even though I have made lectures as almost independent of other lectures as possible, because of the natural linkage and the flow of the topics, there may be some references and linkages to other previous lectures. So don't suddenly jump into aerodynamics lecture 8 or lecture 12 if it has a relation with lecture 2. If I say it has not, it will be already clear. Don't take 6 topics at a time of 6 different chapters and try to mark that up in a single shot. You will feel more confused. Take up 1 or 2 streams, learn the lecture, go through this process as I said, explain and understand, and then second time when you are revisiting, just listen to that lecture. Third time, you should be able to close your eyes, with my voice be able to actually say what I am going to say. In your head, it will be that clear. That's how you will use the material. And fourth revision, if you really want to do, if you are that much interested, should be done only after you have solved all the problems. You have again gone back to your basic other source of references, reading, going through other coachings or whatever reference you may be using, then revisiting back to my lecture series and again revisioning very, very quickly. Like a forward playing, like a movie. Third time we have seen, we know what hero is going to do next and what villain is going to do next. We first play, go to that one particular scene of fight which is interesting, done. That's how you use this study material. And all the best. let's get started. Let's have an excellent, enthusiastic, exciting lecture series on aerospace engineering. Thank you.